Now, this word derivative is a very important word in calculus, and we need to understand what it means, how to find it. First off, we need to find it in terms of its definition, which means utilizing limit notation. So, the definition of the derivative is also referred to as, so when I say this word derivative, what it means here is the slope of the tangent. So yesterday you focused on finding the slope of the secant line, and in your homework you calculated some slope of secant lines. Towards the end you started approximating, utilizing the tables numerically, using the graphs and sliding values very close to each other to approximate the slope of the tangent line. So our goal, and a lot of what we do in calculus, was that we have some value a. It might be like x equals 3. And we want to know at this point right here, here we have some line, and we want to know what is the slope of that line. And it's a very important application in calculus for us. So that slope of that tangent line is very, very important for us. And we also have another name for this. I know there's name, derivative, the slope of the tangent, it being one of them. We also call this the instantaneous rate of change. Or IROC. AROC is what you had learned about before, your algebra classes, your prior algebra classes. You learned to approximate the rate of change, or you found the average rate of change, the rate of change between two given points. Now our focus in calculus is shifting to the idea of instantaneous rate of change. What is the slope at a single point? No other point, no A and B, just the point A. Well, when we talked about average rate of change, we get a point A, which was something like right here, and then we had a point B right here, and you found the average rate of change, the slope. We found that the average rate of change was equal to f of B minus f of A over B minus A. Okay, 2 points. But we also learned that the average rate of change approximates, well, we have a new word for it, of course. We said the instantaneous rate of change. In other words, the slope of the secant between 2 points approximates the slope of the tangent. This was your basic understanding and concepts that we learned yesterday. The slope of the secant line approximates the slope of the tangent for small values of h. Okay, so the slope of the secant, we also yesterday, once again review, we wrote it a different way. We wrote it as f of a plus h, defining this b as the point A plus some distance h away, minus f of A over B minus A. And this is where the calculus is now, and this is where things are about to take a change. So, oh, sorry. All over h. So for small values of h, this is a great approximation. For small values of h, this approximates the tangent line. So the slope of the tangent is approximately, and we say the tangent at x equals a is f of a plus h minus f of a over h. All your homework tonight and our whole focus today is finding the slope of the tangent. That is our premise for today's homework. All the problems are, now, some of the initial problems are going to look rather difficult because you're working on just a notation. But the thing I like about the problems I assigned tonight is that I'm not asking you for the first majority of the problems, the first half of the problems. I'm not asking you to find the actual answer. I'm asking you to set up the work. So you will not be finding the answer like, oh, the slope is 3. Okay, you're not doing that for the beginning parts of the problems, because it'll say specifically in the homework, you do not need to simplify, which means you just.
The problem is the Torah that's changing. Sometimes when you do it, the Torah is, for example, 25. But when you see that, when you run the question, say it's 23. How? Let's explain it.
I don't know what I can't grasp what you're saying.
When I do the question, I put it wrong. The Torah is 25, for example.
Mm-hmm.
But when I try to do so many times, I put the Torah. That's wrong because that is different. The 25 is 23. I try to understand how does that do that? It's a Torah 23.
Are you talking about a problem from last night's homework?
Yes, the two first ones.
They're different. There's hundreds of different problems, Darwin. So it's not just everybody got the same problem 1 and problem 2. So I don't know what your problem exactly looks like. There's hundreds of different problems. I would have to have a screen share during office hours to answer that question. If the answer is 25, the answer was 25 because the answer was 25 from what I know. But I would need, there's not just like everybody got the same first 5 questions. That doesn't know how it works. Now I can also look back though. I can look back to every problem that you did, either you got it right or wrong, and I can check it. But I can't do that unless it's at office hours for individual questions or in that beginning time. So Darwin's question, from what my understanding was he got an answer that was different. He was asking about that problem, but that specific problem I can't view. We can't go over really during the lecture time. That's what I'm here for office hours to do. And there's also, like I said, screen sharing is the best thing on that. So, continuing. Tangent line, approximated by here. So, your calculator uses h equals 1 to approximate. In other words, the slope of the tangent is approximately f of a plus 0.001 plus f of a over 0.001. Now, your calculator technically does something called a numerical derivative, and it does the left and the right. But to the purposes of our argument and understanding, I know it does use 0.001 as a difference, but it's basically, if we were to do this, and as you were doing in your homework problems last night with plugging in numerical values to kind of get what you were getting close to, this gives you a very good approximation. But we want to find the exact slope of the tangent. We want to find the exact slope. We don't want to approximate the slope. We want to find the exact. So if the premise here is that as h gets closer and closer to 0, the closer h gets to 0, the better the approximation we have. So why don't we take h and go to 0? Well, if I were to make h equal to 0, It is supposed to be minus. Oh, thank you. Thank you for over there. That's a minus. If we were to make h equal to 0, we would get 0 over 0, and we don't want that. So what we have is that the slope of the tangent equals, and here's our formula. We're going to take the limit as h approaches 0 of f of a plus h minus f of a all over h. This is how we find the exact, because our concept that we just talked about was, hey, if I take h and make it closer to 0, I get the exact answer. So let me take h equal to 0. Okay, why don't I just take h equal to 0? Well, if you plug h equal to 0, you're always, and you plug in h equals 0, you will always get 0 over 0. You will always get 0 over 0. Okay? So we're going to do what we did last time. And the idea here is that we're going to do some type of algebra manipulation to calculate the value. So there will be some algebra manipulations to calculate the value. Now, I for especially on tonight's homework, I kept the actual problems that you have to do by hand to problems that deal with polynomials. X squared, x, maybe x cubed. So you probably have to do some distributive property, but we'll talk about how that looks. Now, we have a more formal definition because there's an issue that we run into. If I say the slope of the tangent, the question is the slope where? This notation of m tangent or IROC doesn't tell us where. So the notation that we have is f prime of a equals the limit as h approaches 0 of f of a plus h minus f of a all over h. I know, so it seems to be like it's not writing, and all of a sudden all my writing comes up. It's because the school internet is very, very terrible. And when I have to teach here at the school, it's unstable internet is what it's saying. So this right here is what we call the definition of the derivative. At a point. At a point. So this is read as f prime of a, or we could read this as the derivative of f at x equals a. But we should note that both of these, no matter how you read this, f prime of a, the derivative of f at x equals a, they both mean the slope of the tangent line to f of x at x equals a. It's just the notation that we use. So we're still using that rate of change formula. We're using that average rate of change formula that we used yesterday. You're still using it, but now the biggest difference is instead of having two values, x equals 1 and x equals 2, and you plug in x equals for a equals 1 and b equals 2, instead of plugging in there, you're only going to say, I want to find the slope at just x equals 1. All right, I just want to find it. Now, in your homework, some questions will ask you for what is the derivative for it. Some questions will say, what is a derivative at a point? So let's take an example. And I just want to practice setting up. Set up the derivative by definition, at the indicated point. So I want you not to use the in your answer. I want it specific to that problem right here. So A, I want to find f prime of, or sorry, in this problem, f of x is equal to, let's go 5x squared, and we're going to use a equals, we'll go with 3. Now, I don't want to find the answer yet. We'll find the answer in the next part of our lesson. But right now, I just want to, can we write the notation correctly? And how do I go about doing that? So I want to give you kind of like a process to do it. When I do this, I always write out the general formula. All right. I always like to write the general formula. Maybe I'll skip one step and go into and replace the A with 3. That's the only thing I'll do. But for my notes, I'm going to do it all the way out. So what I do, what you do, is we want to, this question is asking for f prime of A. And my formula, and you want to write it down, especially this first time, and I can't tell you enough. You want to write this down as many times as you possibly can on a piece of paper, because you want to make sure you get this formula correctly. F of A, or sorry, the limit as h approaches 0 of f of A plus h minus f of A all over h. Okay. Now that's your general formula. Now let's find it at 3. We're going to plug in we're going to replace the A with 3. So f prime of 3, and this is usually where I start. I started with this one, f prime of 3, because that's what I'm asking, is the limit as h approaches 0 of f of 3 plus h minus f of 3 all over h. Fine, or now so that's kind of like step 1. Step 2, my next step is that I'm going to replace the function with the function for this problem. So instead of calling it f, I'm going to replace, my f is 5x squared. So f prime of 3 is equal to the limit as h approaches 0, and I'm going to replace f. Remember, I find that it's very important, just in case this problem won't matter, but I usually put brackets around the f of 3 plus h and f of 3. If f of x has if f of x has more than one term, if it has 2 terms, then it's very important. So I get the limit as h approaches 3 of 5 parentheses 3 plus h quantity. So I replace the x with 3 plus h squared minus 5x squared all over h. Now, in your homework, this is where right here, this technically is the answer, or this is the setup of the problem. In your homework problems, in the first 2 sets of problems that it says write the derivative, this is all it's looking for. Oh, I'm sorry. I did make a mistake. I got to replace that x with 3. Sorry about that. At 5 times 3 squared. There's every a gets replaced with 3. This is what you write, and if you got this right here and you write that as your answer, that's what Delta Math is going to be looking for in those first 2 problems where it says you do not need to simplify your answers. In other words, the answer, and it says the answer is limit as h approaches 0. You are working towards writing that inside part. The first thing we got to make sure that you do is, can you write the notation specific to that point and that value and that function? Questions? Okay. Try the next one. F of x equals 3x minus 2x squared. A equals -1. So let's look for a negative number for A. If they give you a negative number for A. All you have to do is worry about parentheses, okay? We just want to make sure that we're following the work and that we're doing it. What do I do first?
Writing the general equation.
Good. So f prime of A equals the limit as h approaches 0, f of A plus h minus f of A all over h. Good. Next.
Don't you do f over 3 with parentheses of 3?
Close, but we're not asking you to do it at 3 anymore.
You're doing it at -1.
So I'm gonna find. Can you state it? Can you state what I'm gonna write down?
You're filling in all the x's of -1, so it would be f prime of -1 equals
No limit.
approaches h to 0.
As h approaches 0.
And is this where we put the brackets or no?
You don't need to put the brackets right here now. If you want to, you can put bracket right there.
So I'm confused. So then it would be 3.
No,
It's not 3.
not yet. They're
-1.
-1 plus h. Good. I know that's why I want to do multiple examples. That's my purpose of it, because certain things we feel like it should stay there, and then it's not. And so that's why we need to see multiple examples. Next.
Minus f times -1.
I want to make sure that we're saying it correctly. It's f of -1. Brackets and brackets, that will help me. All over. All over.
H.
There we go. Good. Next one. F prime of -1 equals the limit as h approaches 0 of bracket. And what am I going to write? Now we're going to replace the f part, the function part, with the actual function. And this is pretty much the last step where this will give you your answer.
Is it 3?
3.
Of -1.
Time. Now this is the time. So this is the parentheses. So when we're staying in functions, it's function notation, and we're just using and stating as a function. We say f of, but now we're going to actually replace it with the function. So it's 3 times. The quantity are just 3 parentheses. What do I go in there?
-1 plus h close parentheses squared.
Nope, not squared.
Squared? Oh no, it's not. I lied.
It's okay. Perfect.
Bracket.
Not yet.
Not yet. Why not? Minus 2x, 2, and then parentheses -1 plus h parentheses squared. Then you can end the brackets.
Good.
No, next thing.
Next. So what we just did
Over h.
What we just did is we took care of this part right here. So we did this, and that is this part right here. So that's what that part is. So that's what we've taken care of so far. So that's f of negative 1 plus h. So I guess I could use the colors here to do that. So this is this. All right, now we need to do the other part of the problem though. So minus now we need to take care of this part. Minus what? All you're doing is, don't overthink it. All you're doing is plugging it in. So minus, oops, minus bracket. Okay, so what's f of negative 1? How do I plug in negative 1? I just got to plug in negative 1 to f.
So you do like 3 times negative 1 minus 2, and then you do your parentheses, negative 1 parentheses squared. That's it. Oh, bracket.
And finally,
All over h.
yeah, finally, all over h. And for your first problems, this is all you're going to focus with. Now we're going to work on, right at the next problem, or pretty shortly, we're going to work on what do we do to, to actually do it. After we do the next example, we're going to actually try to work it out. Now, right now, we're not trying to find the actual value. Okay, we're not going to try to find the actual, that's the answer. That's all I'm looking for right now. In the first 2 problems of your homework, that's basically what I'm looking for. Now for the next problem, C, what happens if I give you something that's like f of x equals the natural log of 2 over x, okay? It doesn't matter what function I give you. All you're doing is following the process. All right, my formula, oh, sorry, and we're going to find this at a equals 5, okay? Limit h approaches 0, f of a plus h minus f of a all over h. Like I said, if you feel comfortable jumping directly to this part right here, I'm finding f prime of 5. This is typically the earliest place I'll start. Limit as h approaches 0 of f of 5 plus h minus f of 5 all over h. I typically will start right around here and actually, finding the definition of derivative at 5. And that means it's only a 2-step problem. So this gives me the limit as h approaches 0, f prime of 5, equals, all right, all I got to do now is I got to rewrite down what f actually is and replace where I see an x with 5 plus h. And then where I see an x with 5. I copy down exactly what I see. This is what I see. I'm going to put that in here twice, but I'm going to replace the x that's right here with the 2 inputs that I'm looking for. So doing that, I get what as my first term? I know it's a weird function. Natural log, we haven't even covered how to go over natural logs. It's a function. We'll study it a little bit more and how to work with it later on. Right now, it's just a function. That's all you got to know. Can you use the definition of derivative? Can you replicate? Can you write the formula out as it applies to this one? So what is it?
Is the natural log
Of?
2 over x.
Well, remember, we're replacing it.
Oh, with 5.
We're replacing it with
Plus h.
5 plus h. That's it. So And it stays in the denominator. The whole 5 plus h is just in the denominator. Where I saw an x, I'm replacing it with 5 plus h. Minus the natural log of I'm replacing
2 divided by 5.
2 divided by 5. All over h. So what happens if a is not given? Okay, so what happens if there is no a? Well, we can find it for any value of x, which means that x is in the answer. Okay, so in some of your problems, for 3 of your problems tonight, it just says write an expression, and they don't give a point. They don't give like at x equals 2. They don't say anything like that. At x equals -1. So for example, find an expression for the derivative of f, and I'm just going to write f prime of x, where f of x is equal to the square root of x minus 6. Okay, so this is our problem. I did not give you an a, and it works the same way. But a is basically x. That's the nice thing. Our answer looks exactly the same. We're not gonna replace the a with any number. We're not gonna replace the x with a. We're not gonna replace the a with a number. So while it looks very ugly, it's actually a little bit more straightforward. So here's how we do it. We go f prime of x equals the limit as h approaches 0 of f of, well, it's not, there's no a. We're just keeping the a as x. So it's x plus h minus f of x all over h. It's like the a when in the previous problems when it was a, f prime of a, but you're replacing all the a's with x's. That's it. So I'm basically writing the same formula, but instead of writing it with x, with a, I'm writing with x. And I don't have to replace the a with a number. I'm keeping the a with x. This is equal to the limit as h approaches 0 of, now we're going to use the actual function, square root of x minus 6. Okay, so my first part would be the square root of, now I'm going to replace the x with x plus h. I'm replacing the x with x plus h. So I get what underneath the radical. So what now is underneath the radical? Where I'm turning all the x's into x plus h's. What do I get?
Is it x plus h minus 6?
Boom. Minus the square root of f of x. I literally copy over f of x. So what is f of x? Hint, it's,
X minus 6?
yep, all over h. And this is what those problems are asking your answer to look like. You do not need to simplify. That is the derivative of that function for square root of x minus 6. The majority of your homework is, and the first goal in your homework is, oh, this chair's a little wobbly, is can you use the notation? And the notation and these definitions and these like formula type of things are one of the key components of calculus. Now, so far, we have not evaluated it. We just looked for our answers in limit notation. So in our problems, and I realize, and I almost want to flip the problems. I might flip the order. It looks like the The harder ones with X's are the first problems you see, and then the ones that are easier at a point are the next ones. So you might see me like change the order of the homework, but it's still the same problems. So now, on our final piece of business today, let's find the value of f prime of a, which means we have to actually evaluate the limit. Now, in today's problems, just polynomials. So you don't have to, we're not going to do radical problems. I know that's it's a little bit probably too much to handle too fast for the majority of us. In regards to it, there's a lot to throw at you if I throw at you different types of functions. So we're just going to focus on polynomials, and the truth of the matter is you've already done these types of problems. All right? So let's look at the example that we did earlier. And we're just following up for the example. So we want to actually find the value of f prime of a. We want to actually find the slope of the tangent at x equals a. I think that's how your homework words it. 3x minus 2x squared. So find f prime of -1 for f of x equals 2x minus, what was it? Well, 3x minus 2x squared. Okay. So we want to find it. So we've already done the first step. All right. We've already done the first step. We've already found that f prime of -1 equals the limit as h approaches 0 of 3 times -1 plus h minus 2 parentheses -1 plus h squared, close brackets, minus 3x minus 2x squared all over h. We've already done that. That's from our prior work. Okay, so you're looking in and like, wait a minute, how did he, sorry. So 3 times -1 minus 2 times -1 squared. That's from what we wrote above. Okay, we've already found that part. And in the first parts of your homework assignment questions, that's all you're finding. But on the very last set of questions that you're being assigned to for your homework, we need to actually find the value. Now, we always get 0 over 0 on all of these problems, no matter what. If you plug in h equals 0, you get -1. So your goal is to simplify the numerator, okay, to factor out an h, 3, cancel h, and 4, reevaluate. Those are basically the same steps you're going to get all the times. So we need to expand. We need to clean up what we have. I know I have 5 minutes. This is the last example problem. So limit as h approaches 0. We're just going to clean it up. We're just going to clean it up. So I get, and there's many steps to cleaning it up, all right? There's many ways. I mean, there's not steps. I mean, to say there's many ways. Like you can keep the brackets if you want to. You can distribute them out. I'm going to keep the brackets initially. So I get bracket, and I get -3, and I'm just using a distributive property, plus 3h minus 2 times, and I'm expanding -1 plus h times -1 plus h. Okay, this is the same thing right there as -1 plus h times -1 plus h. So that's distributive property. That's just your algebra. That gives me 1 minus 2h plus h squared. If you're having trouble saying, how did I get 1 minus 2h plus h squared? I just did the distributive property of -1, I foiled. I just did FOIL. Minus parentheses, -3 minus 2 times 1 all over h. If you do this right, every term you're left with in the numerator will have an h. So let's continue now. I'm just expanding. All I'm doing is expanding. -3 plus 3h minus 2 plus 4h minus 2h squared. Actually, I want to get rid of this bracket. I'm expanding it. Plus 3 plus 2. I distributed the negative all over h. All right. What cancels? What cancels in the numerator? Simplify the numerator. What reduces down in the numerator? And like I said, there's a good hint, a good tip. If it doesn't have an h, it will go away in the numerator if you've done this right, 100% of the time. So what about this 3? You notice this 3 right here, and you notice this or the -3 and 3? They reduce out. This -2 and the 2, they reduce out. Anything that does not have an h attached to it will always reduce out if you've done this correctly. So now I have the limit as h approaches 0 of, well, 3h plus 4h, that's 7h minus 2h squared over h. Okay. We now need to factor out an h. Limit h approaches 0, h times 7 minus 2h all over h. The h's will always cancel out if you've done this correctly now. Now, only once you factor though. Only once you factored can you cancel those out. Equals the limit as h approaches 0 of 7 minus 2h. And what am I going to do now? What do I do now? I'm very happy with what the problem is right now. I'm like, okay, now it's an easy final step. How do I evaluate this? How do I evaluate a limit? Come on, we only got 1 minute. How do you reevaluate a limit? How do you evaluate a limit, period? Any limit, no matter what the limit is. If I say evaluate the limit, what's your first step? Come on, I need somebody. The answer is very straightforward.
You just plug in 0.
You just plug in 0. 7 minus 2 times 0 gives me 7. So therefore, f prime of -1 is 7.